So people say, how does ozone compare with chlorine? There's great differences in the two of them, and there's some similarities. But it's all about putting the right amount of ozone, just like it would be with chlorine, in your application. So if you could put a teaspoon of chlorine in your washing machine, and it might sanitize your clothes, but put that same teaspoon of chlorine in your 30,000-gallon pool, and it wouldn't do much. And ozone's quite the same way.
This is episode 144 with Beth Hamil of MicroPlasma Ozone. Enjoy!
Welcome to your go-to podcast for the pool and spa industry. My name is Tyler Rasmussen.
And my name is Greg Villafania. And this is the Pool Chasers Podcast.
Hi, Beth. How are you doing?
I'm fantastic, thank you. I'm very excited to be here.
Yeah, we're super excited. Thanks for coming down from your new farm from Kansas. And, I know all about you moving from California to Kansas. And it truly means a lot that you're here with us today. We appreciate it.
I've heard so much about Pool Chasers and both of you from our mutual friends in the industry. And I was very excited when you reached out to me because I thought if I'm going to do a podcast, I'd like to do it with you guys.
Thank you so much. Appreciate that.
Yeah, it definitely means a lot. So we appreciate it. So let's go back. We would love to get to know you a little bit better. I mean, where did you grow up?
Everywhere. I was born in Newport, Rhode Island. I was a Navy brat at that point, and my dad left the service, and I lived in Washington, D.C., New York. At one point lived in Chicago, did my high school years in the Chicago area, moved back to New England, went to school there at the New Hampshire Institute of Technology, and then back to Chicago, and then at 27, I thought, California's the place I want to be. So I moved to California in 1980, and then 4 months ago moved to beautiful no man's land, Kansas, which I dearly love. So I've been around a little bit.
Yeah, how was it growing up being a Navy brat? I mean, that's got to be a little tough
jumping
around like that.
It was. My dad was Naval Academy right before World War II, and then went off to, I'm very proud of the fact that my father was in the Normandy invasion on a destroyer. So he left the service, so then I really became a corporate brat. So I have 5 siblings, and every one of us was born in a different state. But by the time I came along, my dad had left the service, and so it was really being a move around the country corporate brat. I like to think I grew up in a litter. There's eight of us, 6 kids, 2 parents, and quite the normal, I suppose, growing up years. But I'm grateful that I came from a big family.
I was going to say, were things pretty organized around the house?
When my dad was there, yes.
When Dad was there.
When my mom was in charge, absolutely not. And my dad was, my dad
He's
was
gone. We get a break.
You have no idea. Fast food, yay! Dad's not here.
Not making my bed.
Exactly. I don't have to get the white glove dusting on the furniture. No, my father was gone a lot. He worked for RCA, and they did the first transcontinental underwater cable for communications in the late 50s, early 60s. And then after that, he went to work for Brunswick, and they made bowling balls, but they also, a multi-billion-dollar company, did a bunch of other products. So he was always gone.
That's actually a really cool story because that is during the golden years of radio. Mm-hmm. And I've seen this documentary where they talk about RCA being a pioneer in radio. And it is incredible. I mean, if it wasn't for RCA, we probably wouldn't be doing the things that we are today. What exactly did he do there?
Well, his degree from the Naval Academy was electromechanical engineering. And so I'm not really sure what he did all that much. I think he was more involved on the business side. He went to Harvard and got his MBA. So I think he was more in the business, but he had this background in electrical. But I can tell you that we were the test family for the first color TV and the first remote control TV when we lived in New York in the early 60s. And then he had a cassette tape player, and the cassette was about the size, about 12 inches by 8 inches. And we had this cool cassette player that we would tape messages to our grandparents because we had grandparents in Wisconsin and in Maryland. Anyway. So
That is so cool.
my dad was pretty cool. And interestingly enough, when I first discovered ozone, it was first brought to me, and I'm jumping ahead here a little bit. The first person I called was my dad. What do you know about this ozone stuff? And he provided me with an amazing amount of research, not only just ozone in general, but how to make a machine that makes the ozone gas, so the ozone generator itself. And at some point, it wasn't RCA, it was Brunswick. They had developed an ozone system. They had their little corona, nobody knows this, their little corona cells were actually developed from hypodermic needles because they owned a hypodermic needle company called Sherwood Medical in the 60s. And they were going to develop this ozone system for cooling towers. And it never grew any legs, and so it went on the shelf. But he had all this research that he gave me very early on. Oh, wow. And so that's the start of my education on ozone.
Wow, that's pretty instrumental.
Yeah.
That's very cool.
It seems like your family's been on the forefront of technology then for a long time.
I never thought about it that way, but it could be. I suppose you could say that. At least my dad.
Yeah.
And dragging us along with us. He was by far my best teacher and mentor as I was growing up. He was always willing to share information with me, teach me things. So
What'd you guys do for fun? Like when he wasn't working or you were doing what you were doing?
I have always been a horse lover, so I've always had horses, and I still do. And so my world growing up was go to school, get it over with as soon as possible, and ride my horses. That was it. We lived on a lake when we were in the Chicago area, so we did a lot of water skiing, and we did shoot a lot of skeet. My dad taught me how to reload shotgun shells when I was about 10. I don't think I could do it today. So, just outdoor activities and just getting along with a family of 8 people and not ripping each other's heads off.
Yeah.
Yeah, you told me yesterday you were really into the outdoor environment scene.
I'm very much an outdoor person. I just don't like being inside. I much prefer being outside. I like it a little warmer than 20 below zero. That's a little tough, but I don't have any special sports. I don't have any special skills. I just like being with my horses and like being outside.
Right. It's funny you say horses. Recently, so I've been watching The Crown for a while, and Queen Elizabeth actually makes her way from United Kingdom to Kentucky, doing some stuff in Kentucky, really into horses as well, and is surrounded by, they're at this exclusive ranch and they're going to, horse races and different things like that. And there's a scene where she just like breaks down and said like I wasn't pretty much like not meant to be queen. Like I should have been spending my life with horses because she loves riding them. She loves watching them.
And she still rides, doesn't she?
Yeah.
And she's 90 something.
Oh, yeah. Yeah. But she,
and
if
dogs.
you watch the show from the very beginning to where it's at right now, with Diana, I mean, she's like very, very into it. But I just thought it's fascinating that there's something out there. Like there's this real bond between a human and a horse that people just fall in love with. Because if you're into horses, like you're into it,
Exactly.
Like there's no like, just kind of dabble in it.
Right.
Like our friend Martise, like he's got horses and
he does.
Him and his wife is super into it.
I just learned about that. I've talked to him for the first time a couple of weeks ago when we were in Dallas, and we ignored everybody else and talked about horses for about an hour.
Yeah.
So what are they talking? What kind of ozone are they talking about? Like they're not. They're
talking
it's
about
gonna
horses.
be a while. Yeah.
That's entirely true. I actually felt bad. I went, oh wow, that's all we talked about our horses.
What do you love most about that? Is it a peaceful thing for you, or escape, or?
I think it's a lot. I was 5 when I got my first horse, and my parents had never had horses, and I just insisted that I had to have one. So I think when you're 5 years old, it's just the pony thing, and then I think for a young girl, especially, you have this massive animal who can really hurt you. And I've been hurt many times by horses, but they can really hurt you.
That's the only experience I've had, by the way.
It's the bad experience.
Yes, it's being bucked off the horse.
Yeah, it still happens to me. But there's and there's books and books and books written about, equine therapy, and they're so calm, and they're so zen, and they're so powerful, yet they're so forgiving, and they're so loving. And as a young girl, and even in my teenage years, you know, and you have this teenage turmoil, and whether it's you fill in the blank for a teenager, and the horses, I could always go see my horse. If no matter what happened in my life, no matter what, in my mind, disaster or debacle, you always get this calm with your horse, and I still do. Now sometimes they make me mad, and I'm not calm, like when they break things or whatever. But it's a human equine bond is so strong, and I think it goes. I don't know how long humans had domesticated and riding horses, but it goes pretty far back.
Yeah.
You know, it's kind of like
Almost forever. Yeah.
Yeah.
They've got really old walls in Egypt and everywhere else with horses on them. But I will say that it probably has helped you become the person that you are with ozone and things like that, because you have this other side to you. I think people that have passionate hobbies and can bring balance, it's almost like you can be with your horses and have fun and then kind of come back and, you know, you're just ready to get to it.
I find it fascinating though that the response to humans that they have, and they can feel your emotions. It's pretty documented that the horses, you know, as you get angrier or you get calmer, they react to that. I find that pretty fascinating.
it is fascinating. I'm sure that there's a lot more I could know if I took the time to study it, but my world is wrapped around ozone so tightly that I don't have time for a lot of other things. I have Netflix and I have a TV. I just never turn it on because I like to read. I'm a reader. So, and if truth be known, you guys, if I turn on one of those movies, 10 hours would go by and I would have lost it because I just would focus on it.
I'll say that my sleeping habits are very unhealthy, but I will, no matter when I get home from work, because I usually will go home and come back here after kids go to sleep or whatever and work. But every time I go back home again, if it could be 12, 1 in the morning, I have to like watch like something for an hour. Like I have to. And it's usually like a documentary. Like I really only like documentaries, and like I love Crown because I'm really into just all the kings and queens and the history behind, you know, why they do things. And it's also because like a full day from morning till when that time of night, not really doing anything of that sort.
Right.
So it's like finding that time.
Like decompressing.
Yeah.
Yeah.
But I'm always really stoked for it. Crown is so good. My wife trips out on that. She's like, The Crown? Like I gotta find a meme for that. It's like when you're with all your guy buddies and they're like, yeah, what cool movie? What show are you watching? I'm like, oh, The Crown. What? The Crown?
It sounds good to me.
It's hilarious.
So tell us more about, you went to school, you said, and where was that at?
New Hampshire.
What did you do?
So I was, my whole plan was to be in nursing, and maybe even, I don't think I ever thought I'd be a doctor. I never thought that far. But I was enamored with the operating room. So I was an operating room scrub nurse. I went to nursing school. I did not become an RN for a multitude of reasons. Number one, I was married and I had my first child. So I worked in the operating room with a baby, and you have to take call. And my husband wasn't keen for taking care of the baby when I had to call off to a case in the middle of the night. So I actually abandoned the whole medical industry. Quite frankly, I don't know that I've ever said this publicly before, I did bookkeeping. I thought I could do bookkeeping. I did it on the side. Did I know what I know about bookkeeping? Whatever I read in a book. And because it's a book, right? Bookkeeping. And I got involved in the construction industry, dabbling. And then I discovered the hot tub industry. And that's a really long story. I don't want to waste all the time on how I got involved in the hot tub industry. But I did. And I worked for a company called California Cooperage. It was, by then I'd moved to California. They eventually became Coleman Spas. And Coleman Spas was in Chandler, Arizona. Yeah. I don't know who they are now, but they bought California Cooperage. It was in San Luis Obispo. And I ran the customer service department.
And that's where you lived, right?
Yeah, by then I moved to San Luis Obispo. ran the customer service department. We had lots of problems with the product, and I complained about the engineering department constantly. And so the management said, well, if you think you could do a better job, you could have the job. I went, all right. So I became the engineering manager without an engineering degree, but I did have a pretty good background with my dad. And as I mentioned before, I ran this engineering department. I didn't have to be an engineer. I just had to be able to herd the cats of engineers are tough to herd. And so that lasted until Coleman came to buy the company.
That had to do with like the wood, right? You had problems with the wood.
So it was
around the
everything.
spas.
You know, when at a hot tub company, you buy trees. At least you did back in those days. You buy trees, and everything was done by hand. So we had the first computer system. It's called Materials Requirement Planning, MRP, which is now called ERP. So we had to develop part numbers for everything. So you buy the tree, and then there's another part number when you have to cut it down, and then you take off the bark, and then you put it through the planer, and then you put it through the mill, and then of course we had all the support equipment. So we had a pump and a filter and a heater. In those days, it was Hayward and Raypak and Teledyne and A.O. Smith, and so it was building these redwood hot tubs. And where the ozone came in was if you put chlorine in a redwood or cedar hot tub, it will delignify the wood, and delignification is the process of turning wood into paper pulp. So somebody said, well, you should try one of these ozone generators. I'm like, what's an ozone generator? Hey, Dad, what's an ozone generator? And that's how the whole thing got started. We started testing it, and we figured out how to put it on the hot tub. And in the old days, we hot tubs, just like a spa of today, has a venturi in the jet. So you aerate your jets. I think they still do it that way, unless they've come up with a new way. No, so we'd tap into one of the jets, and that provided the vacuum that would suck the gas out of the ozone generator and theoretically dissolve it in the water. And I was so intrigued by it. And the guy who owned the generator was a distributor in the swimming pool industry. The guy's name was Don Kern. It was Kern Products. And he also owned Beachport Spas. Then I think CPM, which was all part of Kern Products. They're a big distributor. They were the biggest tabletizer of chlorine tabs. They'd buy it and they'd tablet and sell it. It eventually became Superior, which eventually became Pool Corp. It all evolved over the years. And he decided to sell everything but the ozone part. And Coleman was getting ready to buy CalCoop, and he came to me and said, I want to move to San Luis Obispo. I want to just take this company and do nothing but ozone. Are you in? I said, I'm in. And that's how Dell Ozone got started. Dell Industries at the time, which became Dell Ozone. Don Kern is the D in Dell. It was, nobody knows it's an acronym. It stood for Don, Ed, and Larry. They were the original partners. We started Dell Ozone. There was 4 or 5 of us when we started it to take this technology that we've been using at CalCoop to sanitize these redwood hot tubs and just and develop it and figure out how to make it better. And so we hired a PhD or two and opened up the doors and became Dell Ozone. And in those days, we were making ozone with an ultraviolet lamp. So there's 2 ways of making ozone. Ozone's made with light energy or electrical energy. And the light energy in nature is the ozone layer that protects the Earth. The electrical energy in nature would be a lightning bolt. It makes ozone. The windings on an electric motor make ozone. The light in a Xerox or a copper machine makes ozone. That's UV. Lots of different ways of making an arc welder makes ozone because of the electrical energy. So we started off with the UV lamp because it's smaller, it's less expensive, and we were learning. And we eventually grew from there. We went from a spa jet to a Mozzie injector, met this guy named Angelo Mozzie, and worked on getting an ozone introduction through a Mozzie injector. Far better mass transfer efficiency. Still to this day, it's by far the most efficient way of dissolving ozone into water, and it's very inexpensive, comparatively speaking.
What year was that? So they're still
when
doing
we
it
did
to
the
this day?
Mozzie with Angelo, I think it was 81, maybe 82, maybe 83. I don't know. It's a long time ago, you guys.
And at that time, was that like the first UV in the spa?
It was the first UV ozone for the spa industry. We make sure we don't mix up the 2 UVs. You've got germicidal UV, which is 254 nanometer, and you run the water by that, or air if you're doing air purification. And it's the beams of light that actually, I don't know how deep I want to go into. They don't kill things. They affect the RNA or the DNA, and they disable their replication.
Yeah.
So if they can't replicate, they can't infect. And they do a few other things. There's some data out there that says it helps to break down chloramine. I'm not very well versed on exactly how that works, and not my thing.
So that's one version of UV.
So that's one version of UV. The other one is UV produced ozone. So you have 185 nanometer, and you run as the air passes by the lamp, the oxygen molecules in the air come into contact with the intense light energy, and some of the oxygen molecules are split into O1s. You know, oxygen in nature has a very strong bond. It's always an O2. It's got a double bond. It takes a lot of energy to break that bond. And when you can use the UV light, like the sun does, to make the ozone layer, or electrical. And in the case of UV, it's the UV light that is splitting some of these oxygen molecules. A free O1, it reconnects to another O2, and that's what O3 is. That's what ozone is. It's oxygen with a third. It's called a triatomic allotrope. Tri, 3, atomic atom, and allotrope means it doesn't exist that way naturally. It has to have an external energy to create this allotrope, which is getting too deep into what we're doing here. But that's an ozone molecule. So we did that with the ultraviolet lamp because they were very inexpensive, and we didn't need to make that much ozone, or so we thought in those days. And we were just doing hot tubs and spas.
Sure.
So we went from hot tubs to spas, and really Dell grew from the spa industry. And I think it was easy for us because we all started out spa manufacturers. Don was Beachport, I was Calcoop, and we made spas then too by that time. And so we knew the industry, we knew the people, we knew who the manufacturers, and we knew how to do it. So we were very successful at manufacturing ozone generators for the hot tubs. I call them hot tubs. They're all the same to me. Hot tub spa, synonymous. We sold a lot of them, hundreds and hundreds of thousands of them over the years. So we would develop a specific one for, I don't even remember all the manufacturers anymore, say Coleman or Watkins, which is Hot Springs, Cal Spa. If you named a spa manufacturer, I would say, yep, they had a Dell ozone on it. And then we thought, well, if we can do a hot tub, why not do a pool? And in 85, we had the first NSF listing ever for an ozone generator for the recreational water industry, whether it was a hot tub or a spa. We started with hot tub. So we had NSF, National Sanitation Foundation, Standard 50 is well known in the swimming pool industry. It's a commercial standard, but it gives a residential pool homeowner some confidence that the product they're buying has been vetted by a third-party ANSI accredited lab, which I'm a huge fan of and always will be, no matter what product you have. To get a standard 50 listing, it's not easy. And you're getting a listing for the components of your product, the longevity of the product, looking at your product claims. If you say it makes X grams an hour at X percent by weight, that you have to prove that. And then the longevity of the product, they abuse it for you have a cumulative total of 9,000 hours. So it's a difficult. And then you have to show microbial efficacy. So you have to kill Enterococcus faecium, Pseudomonas aeruginosa. You have to have a 3-log reduction, which is a 99.9% kill in a single pass, and you have to do that in 5 passes. So you can't make stuff up. Whatever your claims are, you have to do what you say you do. So we got the first NSF listing ever in 85 on our spa unit. So what we ended up doing was growing. We thought if we can clean up a spa or we can sanitize a spa, we got this NSF listing that said that this ozone generator was equal to or greater than a 2 ppm chlorine residual in the water when they inoculated the water. That's how the test worked in those days. And we had to prove that we made the ozone that we claimed we made. A very small, relatively small ozone generator. So we then made bigger units for swimming pools. So over the years, we went from spa size, and we're still using UV, to a much bigger unit, bigger lamps, more amounts of lamps. I think we had a 40-inch lamp that we had bent into a U shape so we could fit it in a smaller can. That was fun. So eventually went to swimming pools, and then we did some commercial applications. We went into, I'd forgotten about this one. We had a machine that would connect with a compressor to underwater tubing for lakes. And there was a guy in the Chicago area who invented this tubing. It's extrusion of tubing with a metal weight on the bottom. So you'd have this roll of tubing. You could go out in a boat and put it in the bottom of a lake, and it would land right side up. And then it had these laser slices on the top of it, and we would bubble the ozone gas into this tubing that went around the lake. And you had, it's called laminar flow, and I'm going really back into my memory thing. So as these bubbles would rise up from these slices in the tubing all over the lake, the water volume would go down. So you had actually, we were recirculating the water, bringing the bottom of the water in the bottom of the lake up to the top surface where it gathers oxygen, because of that's the Henry law, Boyle law, and I don't claim to be an expert on. And we could bring dead lakes back to life and control the algal growth by actually circulating it just through this laminar flow of these bubbles coming up. Wow. Simultaneously, the ozone would, very low levels of ozone, the ozone would keep those laser slices patent, or keep them from growing any algae on them so they didn't clog up. And that was quite the product. And then somebody who worked there took off and ran with that, and we provided them the system for it. I mean, I'd forgotten about that one. There's a lot I've forgotten about it, I promise you. And we did some whole house water systems where we used ozone, and we used UV, and we used carbon filtration and particulate filtration for a whole house drinking water system, which are very cool, but they're very expensive. And now you're dealing with homeowners. As a manufacturer, that's tough because it requires a lot of people. Mm-hmm. And so we sort of abandoned that one. But we got into bigger swimming pool units, and then we just discovered that we couldn't make enough ozone with the UV systems. And we really weren't making a big impact on the swimming pools. So then we went from light energy ozone to electrical energy ozone, and that's where corona discharge comes in. So we spent many years developing our corona discharge ozone generators, not only for, quite frankly, we did the commercial systems first, then we went back and did the residential system. So we got in, then we started to, at that time, we were going to go into commercial swimming pools. Really, we had a big boost in our business with commercial aquariums, because a commercial aquarium cannot function without ozone unless it's in close proximity to a body of water where they can recycle the water. As an example, Shedd Aquarium in Chicago utilizes Lake Michigan water, or SeaWorld in San Diego, or SeaWorld on the water. They can pull in ocean water and keep the animals healthy, whether they're fish or sharks are fish, mammals. Dolphins, mammals. Yeah. And so actually SeaWorld was I think they were pretty instrumental in working at developing the use of ozone in a landlocked aquarium, or to enable a landlocked aquarium. So ozone took off in the aquarium industry, and we made a lot of ozone generators for commercial aquariums. And then that just went globally, so Beijing and, Saudi Arabia and Dubai and literally all around the world. So we just made bigger and bigger ozone systems. And it's interesting because in a commercial aquarium, it's really not that different than a swimming pool. The sizing is a bit different. Depends on if there's fish that are breathing the water versus mammals that are living in the water. They don't breathe it. Hippo or an elephant pool has more bather load than a dolphin pool, just because of the excrement. It's massive. And then some aquaculture, or some fish farming. So we got pretty good at that. And we took our knowledge, literally, it all goes back to the hot tub. Because if you think about it, you have a body of water that's 102 to 103 degrees. You have people sitting in it. You're bubbling the water. You have an air bubbler. You have jets. And people's faces are right above the water level. And the stuff that falls off the human body when you're putting water that hot and just recirculating it. So we could kill the cooties. We could keep the water in pretty good shape. And we didn't off gas in people's faces because ozone off gas is an unacceptable zero tolerance. And if we figured how to do that with a Mozzie injector and the way we had it plumbed, taking on these bigger projects was infinitely easier. We just needed more ozone. And so during all of this time, you're learning and doing studies and reading papers and learning about the hydraulics. So in order to be an ozone person, you need to know the chemistry, you need to know the engineering, the mechanical engineering, you need to know the electrical engineering. When you're making the ozone generator, you need to know microbiology. So it encompasses so much when you're involved in ozone and you're providing a product for end users, and you have to be efficacious and you have to be safe. I like to always say that the success of ozone is the balance of efficacy and safety. So you want to be efficacious in killing the cooties. That's my technical term.
Yeah.
and being safe for humans and safe for the environment. So you're tying this whole thing together. So current discharge, larger generators, figuring out how to get the ozone in the water and be as efficient as possible, your mass transfer efficiency, you're dissolving it in the water, you get rid of the bubbles so you're not having any bubbles migrate off the surface of the water that may have ozone in them. You have oxygen as a feed gas, you make much more ozone with a smaller footprint, less energy, and higher concentration, so you get more of it in the water. So the aquarium industry morphed into commercial water parks, morphed into commercial pools where all of this rec water happened. And then, actually, in the 80s, we thought, gee, if you can put ozone in water, drink it, which is what bottled water is, why not put ozone in water and wash fruits and vegetables with it? Why wouldn't that be a grand thing to do? So we'd gotten involved in apples and cherries with some growers in the Pacific Northwest. And we developed a system, again, flow dynamics and the plumbing never really deviate. There's some modifications, whether it's a hot tub, a spa, or you're putting on a system for a flume that's moving cherries or apples. And you just need to get more ozone, and the water's cold. You can dissolve more ozone in the water. We did that. We were extraordinarily successful, especially with cherries, because these cherries will float in a flume that has, as I mentioned before, 200 parts per million chlorine, 300 parts per million chlorine that's floating in there to kill the microorganisms. And the stems turn brown and brittle. And when you take a bunch of cherries and you put them in a flat, because they sell them in flats, the brown brittle stems poke a hole in the other cherries, so you lose a grade. And when we ozonated them, we killed the microorganisms, but we didn't brittleize the stems, so they didn't poke holes in the other cherries. So they went up a grade, and that's $1 a flat. They do 1 million flats in a season, or 40 million flats, something like that. That's a lot of cost savings for them. It was huge for the growers. Yeah. So one of them said, so what's the FDA's point on this? What's their take on it? I went, you can put it in water, you should be able to put it on your cherries. Wrong. I was wrong. It was against the law. It was against the law to put ozone in the water and sanitize your fruits and vegetables with it. So we abandoned it. And that was
that?
Huh?
Why is that?
Because we didn't believe we had the clout, the time, or the resources to fight City Hall, essentially, to fight the federal government. We just didn't. We didn't know what we didn't know, quite frankly. So we abandoned it. And in 1998, and we did all the stuff I was just describing, in 1998, the ozone industry as a whole got together and said, there's so much data out there on the safety of the use of ozone. We're going to get together and we're going to gather. Dr. Rice, the man I mentioned way back when, was instrumental in that. And I think he probably got me involved in it. I don't remember. It was a group of people. So the industry put together this massive document. If the non-electronic version would have filled a couple of file cabinets of all of the data out there on the use of ozone, its safety and its efficacy. And the way the law is written under FDA, in food processing, FDA has jurisdiction over some, USDA has jurisdiction over some, EPA has jurisdiction over everything if you're talking about surface sanitation, and then USDA organic hadn't even been invented yet, but that it eventually was. So to make a long story short, after it took a few years, there was a couple of false starts, but the FDA approved the use of ozone as a food additive on June 26 in 2001. And that opened the door for people in the ozone industry to go after the food industry. The problem was, kind of like it is in the swimming pool industry, everybody who could made an ozone generator and said, yeah, here's ozone, it'll take care of everything. Nobody knew what the dose should be, what the CT values are. CT value stands for concentration times time. So how much dose for how much time for X amount of kill. And that's true for the pool industry as well, but the commercial side. What's your CT value for killing Cryptosporidium parvum? It's 0.75. So in 30 seconds, 1.5 ppm of applied ozone will kill crypto, 99.9% 3-log reduction. I could talk hours on that and put you guys to sleep. Sorry about that. So what we did is ran studies. I called the tox group at NSF and said, you've got a food division. What do we need to do to develop our CT values for, and what log reduction do we need to have? What are the laws? And so EPA had laws, FDA had laws, USDA. And so it was a matter of getting on an airplane, flying to Washington, going to the FDA, knocking on the door and say, hey, I'm Beth. I do ozone. What do we need to do? I actually did that. And I did the EPA. And, sometimes you don't know what you don't know. You don't know that you can't do it, so you think you can do it, so you do, kind of a thing. And so we ran studies for a couple of years, and we did it through NSF Talks. We followed what are called AOAC methods that are required, but under different government agencies, under different CFRs, which is Code of Federal Regulations on whatever it is you're working on. We came up with CT values. And so, and then you have to have an EPA establishment number. If you're ozone, if you're a chemical, if you're, chlorine or fill in the blank for any chemical, you have to have, you guys know what an EPA registration number is on a chemical, right? I mean, you've done, everybody, if you're in pool service, you got it on the, so since ozone, you don't have a registration number because you can't contain this, it doesn't leave a residual, it's just a different entity. So it's called a device. And ozone.
You're talking about for like hazmat materials?
Mm-hmm. Yeah. Efficacy claims and everything, it all ties together on an EPA registration. So if you've got a chemical, you have an EPA registration number, and then you have a label. And the label says, this much chemical will give you this much kill over this amount of time. Kind of a CT value. Technically, it is a CT value. And here are the safety and, the MSDS and all of the stuff you do with any chemical. Well, the same holds true for ozone. Except you have an EPA establishment number because you're a device. And a UV sterilizer has an establishment number as well. So does a mousetrap, you guys. Hits their devices. So under EPA law, if you're an ozone manufacturer, you have to have an EPA establishment number, which is very easy to get. But legally, if you're making claims, you need to be able to have third-party validated data that substantiates your claims. And so we chose to do that. And a lot of ozone companies haven't done that. In all fairness, if they can prove what their output is, they can maybe fall back on some other study. But really, legally, you need to have those data on file in your establishment we're an establishment that makes a device that has this establishment number. So all of that stuff was learned, so you're a student of government regulatory as well as testing agencies and how you go about testing and what the right way is, what the wrong way is. You can kind of see how ozone will capture you, because as soon as you think, I know pretty much, let's do this frontier over here. And then you're starting all over again. But all of those lessons, all of those data that you have in your head benefit any application you're doing with ozone, whether it's a swimming pool and I know a lot about ozone in food, or whether I know a lot about ozone in food and it's a swimming pool. The basics are the same. The doses will vary a lot because water temperature varies, the load varies. It's really all about the bather load. So people say, how does ozone compare with chlorine? There's great differences in the two of them, and there's some similarities. But it's all about putting the right amount of ozone, just like it would be with chlorine, in your application. So if you could put a teaspoon of chlorine in your washing machine and it might sanitize your clothes, but you put that same teaspoon of chlorine in your 30,000 gallon pool, it doesn't do much. And ozone's quite the same way. So,
Right. Well, hey, let's back up a little bit because there's probably a lot of people listening that might not know a lot of that, including myself, and that's okay. So maybe you could help, share what ozone is exactly, and maybe explain it in a way that somebody that might be new to the pool industry, new to just water engineering in general, the science of it.
mm-hmm.
Maybe you could just kind of break that down for people to understand.
I'll try really hard, and you guys just stop me when I go off into the ether. Ozone is a gas that's made up of 3 atoms of oxygen, and we make ozone gas with light energy or electrical energy in a box. So we use ambient air, and we either turn that into oxygen and then ozone, or just ambient air turned into ozone. So it's a gas, and that's all it is. It's just a gas with 3 atoms of oxygen, which happens to be an extraordinarily strong antimicrobial oxidizer. So that's what we are. We're an oxidizer. You think of chlorine, it's an oxidizer. Ozone is an oxidizer, and it kills microorganisms by oxidation. So it's not a poison. Everything's a chemical. Humans are chemicals. It's an oxidizer. So it goes in the same category as fire or oxygen. You know that if you set an apple out in the air, it will get brown, which is essentially rust because of oxidation just from oxygen in the air. So they're all oxidizers. Fire is an oxidizer. So that's it. That's an ozone generator. It's a box that has ozone gas. Sometimes it has a lot, sometimes it has a little. You get a bigger box, different technologies, you can get more gas. But essentially, it's a box with gas in it that doesn't do anything but just sit there until you take that gas and you put it somewhere. So you can take the gas and you can put it in this room, if nobody's sitting in here, and kill microorganisms in the room. It kills mold, it kills mildew, it kills algae, it kills all known microorganisms. There's no microorganism that we know of that ozone won't destroy. And it does it by oxidation. It burns it up. So this ozone molecule or a bunch of ozone molecules bump into this oxidizable surface, and it just oxidizes it till there's nothing left but carbon dioxide and water, which are the basics of life. That's it. That's all it does. So how do we put it in a swimming pool? Well, you have a box. You hang it somewhere, the fence, or like we looked at yesterday, is hanging on the fence. And then there's a tube. And then something has to pull that ozone out of that box. And so we happen to use what's called a Mozzie injector. It's a venturi that gets plumbed in the water line. So your return line in the pool, we plumb the venturi in. And as water passes through the venturi, it's got an inlet and an outlet, and then there's a little port on the top. So as the water is passing through the venturi, it gets skinnier in the middle. That skinny part creates a turbulence, which creates a vacuum, which pulls anything into the water. If you didn't have anything hooked to it, it would just be sucking air into the water, and you'd have air bubbles just like your spa jet. It's essentially the same thing. So we hook the ozone tube from the ozone generator into the venturi, and we're sucking the ozone into the water, but we're doing more than that. With a Mozzie injector, and I say Mozzie, that's a brand name, but it's a most commonly used brand name. It's effectively dissolving the ozone gas in the water. It doesn't dissolve all of it, but it dissolves most of it. So an ozone molecule that's not dissolved in the water will be floating in the water as a bubble. And it may bump into something, not very likely. It's going to bounce right off. It's just going to rise up the surface and pop into the air and just go away. You want to effectively dissolve that ozone gas in the water. Once it's dissolved in the water, you don't see it. It doesn't look like a bubble anymore. It's dissolved in the water. That's when it does its best work. So that's the goal of any ozone applier, is to get that gas dissolved in the water. So what do we have?
Does the gas need to turn into a liquid form before going in, or I'm just curious for myself what is actually
I know
happening.
you are, and I will probably stumble over that because I'm not a chemist. We literally dissolve the ozone molecule in the water. We're not turning it into a liquid. It's a dissolved gas in the water. You can do the same with oxygen. You can dissolve an oxygen molecule into the water. Beyond the mechanics of explaining that is out of my realm of expertise. I can't.
It's totally fine. I guess I'm just now a little bit curious because it's like gas being like introduced to water. I know I was just a little bit.
It's okay. So that'll be a paper look up so we can explain it better next time. How's that? but it has to be dissolved in the water.
Okay.
Pentair is adding technology to help ease the experience of owning a pool. Take control of your pools with their all-new automation control panel, IntelliSync, and the Pentair Home app. With the IntelliSync, you will get affordable automation, 24/7 pump control by monitoring via the Pentair Home app, easy installation, which will actually allow you to plug directly into a 120-volt outlet, freeze protection, which helps safeguard the pump in cold weather conditions, and you will receive maintenance alerts to stay ahead of any issues. This can all be done through the Pentair Home app, which allows the ability to command all of a home's water systems at any time. It gives your customers peace of mind by giving them instant status information and monitoring from home or away 24/7. It notifies them when equipment needs attention, and it has the ability to connect them with a trusted professional like you. Stay smart, connected, and protected with Pentair. Learn more about the IntelliSync and the Pentair Home app at pentair.com or click the link below.
So you always want to get rid of the undissolved ozone, even though it's a small amount, so you don't see any bubbles. You don't want to see bubbles in the aquarium. You don't want to see bubbles in a swimming pool. And there's going to be, if the ozone generator is sized properly big enough, there will be ozone in those bubbles, and you don't want those breaking off the surface of the water. So you degas the undissolved.
Very good.
Any undissolved gases.
That's interesting you said you don't want to see bubbles because, I mean, what most people have told, I think, our industry is that how do you know an ozone system is working is, the thing is on and there's bubbles in the water, right? So you know it's working. But now you're saying...
I've always said this. I mean,
you have.
You're just hearing it now, but no, that has been, and I write that in some of my teaching seminars in the olden days, or even today still, what I would consider ineffective or inadequate ozone systems, they're dumb. There's indicator light that says it's on, and then look for the bubbles in the pool. And I'm aghast. No, you don't want to see any bubbles in the pool. Not only are they, as a pool person, you see bubbles in the pool and you don't know what ozone is, what's your first thought?
That there's an air leak.
There's an air leak somewhere. Yeah. And, years and years ago, we made a system at Dell, it's literally back in the 80s, where we bubbled the ozone in, similar to what I just described in the aquarium. And we had these little diffusion stoves that were plumbed into the bottom of the pool if it was new pool construction. And there were some people, and so it was like champagne bubbles that came out, and the pool was lit and they came out here. It was sort of like a water feature. And in that case, people thought they were really cool. And my favorite customer was Tom Selleck, who said, I love swimming through the champagne bubbles. This is back when he was Magnum PI. That was pretty cool to meet Tom Selleck then. Yeah. I was like, oh, yeah. So in that case, it's like a feature. It looks kind of cool, but the mass transfer efficiency was no better. It's still a 15% or so on a good day, mass transfer efficiency. Sure. So they noticed a difference in the water. They did, but it's a waste. The reason it wasn't dangerous is because it made such a small amount of ozone. There was very little ozone bubbles in there. And you could probably say the same thing for the companies that sell these ozone systems and say you can tell it's working by seeing the bubbles, leaving the bubbles in the water. But I'll tell you that if you have a pool with a vinyl liner, they have they're generally blue, kind of blue marbly look on them. And you are bubbling ozone, you're putting ozone in the pool, even with a Mozzie, and you don't degas it. It's coming out of one or two of the returns, and the water comes through the through-wall fitting, and then the bubbles just go up the side. It'll completely bleach out that liner. It'll take away all the color of the liner. It'll bleach it. Ozone's an extraordinarily effective oxidizer, and bleach is an oxidizer. Bleaches by oxidation, so it will bleach the liner. It won't poke a hole in it. Oh,
I told you it was working.
Yeah,
exactly.
So back to ozone, what is it doing? Because I'm thinking about this box. I mean, we were fortunate to go visit one of Jeremy's pools with Premier Paradise yesterday. And I was thinking a little bit, this box. Is this, I'm thinking like a propane tank or an oxygen tank, something that you fill up, when it's empty. Does this box get empty, or is there some natural way of, it getting filled? Like, what exactly is going on there, and what is it doing to the pool?
Okay. So
sorry, that was two questions. Let's talk about the box first.
Okay. So I was going to say, we'll do the box first. So we were on the same page. Back to what I mentioned before. So in this box, there is no gas that you put in. There is no storage of gas inside of this box. It's just a box with electrical stuff in it. The main parts of an ozone generator are the power supply and then the ozone producing cell. So all this ozone generator needs is access to ambient air. And in some cases, it's a two-step process. We start with ambient air. We run it through a compressor. It goes through a couple of sieve beds. And as the air is being pushed in there, we're removing the impurities, we're removing the moisture, we're removing the nitrogen, and the end product is oxygen. So it's not a tank. It's produced in a box that sits next to the ozone generator, and that box is called an oxygen concentrator. And quite frankly, if you ever bought a bottle of oxygen for welding or whatever, home health care or something, that oxygen that's in that bottle was made in the same way with a much bigger version. So we have a miniaturized version of it. And there's even a smaller version, and most people may not have noticed, but they've probably at one point seen somebody who has like a COPD, and they have a nasal cannula, and they used to carry a tank behind them, but they have to breathe oxygen all the time to be able to get out. Now they have a little backpack, a little purse thing, it's a little box. That's an oxygen concentrator. So this is a commercial medical grade box that hangs on the wall, and they're very, very robust. They're designed to do this. So that's one half of our gas. That makes the oxygen. In some cases, we don't use oxygen, we use ambient air. And in that case, MicroPlasma Ozone has a dehumidifier. So it's a solid state electronic dehumidifier. We're removing the moisture. And we want to remove the moisture because an ozone generator doesn't like moisture. And we could talk about that in a second. But let's answer your question.
So now what I'm getting at, and correct me if I'm wrong, is this a process where it's like the air and oxygen that we're breathing right now is going through a system, through your system, where it's going through, it's being pulled in, and then it's like the sort of internal engineering that's in your equipment, it's passing through to get to a certain point where it then ultimately is put into the pool?
That is exactly correct.
Okay.
This is exactly correct. So the air we breathe, any air, make a difference if you're in the Himalayas or you're in the desert. Air is air. I get you've got more oxygen in some areas and less oxygen in the Himalayas, but we're not going to do that there. But we can accommodate that.
We'll talk about Himalayas. We'll talk about Himalayas.
No. We've been everywhere. So yes, it's the ambient air that is in the world, and that goes through a simple process or a little more complex process. So we're either using oxygen or we're using oxygen-enriched air is what we call it, because it's not 100%, it's 94% oxygen. That then is pulled into this box that is the ozone generator. So in this ozone generator, we have a power supply, and we have an ozone generating cell. Now that ozone generating cell, for ozone in general, can be an ozone producing ultraviolet lamp. It can be a corona discharge, which is a high voltage electrical discharge, or it can be a plasma, which is a modern version of corona discharge. It takes it a step further. It's more consistent in that a corona discharge is a random discharge and a plasma is a uniform glow. This is the technology inside of the ozone generator. If you have a small unit, you make a small amount of ozone. If you want more ozone, you just have a bigger unit. So it's like the difference between you've got a go-kart versus the space shuttle. They're both engines. One's a little more complex than the other one, but you just need to go faster in this one, faster, longer, farther. So the ozone generators they get bigger and bigger and bigger. There are ozone generators, so I'm going to answer your question. So in this box, the essentials are the power supply and the ozone generating cell, which in my world right now, that ozone generating cell is a plasma. And that's the only world I want to live in, is where we have plasma, whether it's a microplasma or a much larger plasma. It is the way of the world for ozone. It's the present, and it's going to be the future, and it's going to be around for quite some time unless somebody invents something else, which is not going to happen in my lifetime, and not likely, maybe some modification of the plasma. That's really all there is to an ozone generator. The rest of what's in that box is the management of those two items. Now, and we talked yesterday, there's two halves to an ozone system. One half makes the gas, the other half manages the ozone gas. And in that case, I'm talking about managing it in the body of water or your application. Inside the ozone generator, it has to be smart enough to measure itself and make sure it's doing what it's supposed to be doing. So, and then you can take that a step further. So if it's just a basic ozone generator, you've got a power supply, you have an ozone producing cell, you may have a light that tells you if it's got power or no power, you may have a cooling fan, you may have fuse or a circuit breaker or something, so if something shorts out, it doesn't electrocute you. And that would be the basics. And what I feel is the absolute best ozone generator is a commercial system that's been miniaturized for a residential application. So in this case, the driver is paying attention to its output. It's self-adjusting as conditions change, whether it's temperature, whether it's humidity, whether it's barometric pressure. I'm not an electrical engineer, and I'm not a driver expert, so that's kind of my layman's terms. Also, that it knows that the cell is in its proper operating condition. If the cell is overheating or something is not right on it, the driver can tell because the power changes, and it either adjusts or at some point it says, uh-oh, something's wrong, and it shuts the power off to 1 cell, 2 cell, 3 cell, however many cells are in there. So it's a very smart machine. And then there's another control board that's measuring the gas flow. So you want to have X amount of gas flow for X size machine for X amount of ozone based on what's coming from your Mozzie in the pool. It tells you if you're in the right parameters. If you're out of parameters, it'll shut itself down. It's measuring the humidity, it's measuring the temperature. If it's too hot, like 100, I know the inside's 160 degrees F. I believe if it gets above 122 F externally, it will say it's too hot to run. I'm shutting myself off. If it goes below 40 degrees Fahrenheit, it's too cold. It's going to shut itself off. And it'll auto start when the temperature goes into range. It's got an internal ozone leak detector, which is kind of like a suspenders and belt because the system won't run unless it sees vacuum. But if there's something crazy and there was an internal leak, it would shut it off. So really the way the machine works is you mount it, you bring power to it. Generally, you run it in conjunction with the pool pump power. If you don't, it's fine. If it's hooked up by itself and the pump turns off, there's no vacuum. The machine will just sit there and be in idle mode. It'll just wait. So I think it's kind of cool because you've got a high-tech piece of equipment with a line that's directly into the water line in your pool. So the first thing you'd say is, oh, good, you need a check valve in there. And yeah, it needs to be protected. Check valves will always fail. That's one of I think if you had people listening to this podcast that have put in ozone systems, they'd say, yeah, I've seen check valves fail and the water went in the ozone generator and the ozone generator, burned out or quit working. We opted not to do that. We do it all electronically. So there's a solenoid valve with a very fast shutdown. So the way it works is you turn the machine on, or the machine goes on automatically because the pool pump started, like we looked at yesterday. Here's what's happening. Let me see, make sure I get this right. So the first thing that happens is there's a vacuum sensor. And the vacuum sensor kind of peeks open a little bit and says, do I see vacuum? I don't see vacuum, everything's shut. As soon as it says, I see vacuum, then it tells, okay, solenoid, we've got vacuum, open up. The solenoid opens up, and then it says, okay, flow sensor, tell us what the flow is. And it says, oh, you got good flow, or no, you don't have good flow. Oh, it shuts down. And then it tells you, I'm not broken, I just don't have enough flow, so I've got everything in standby. So then once the flow is done right, then the flow sensor says, okay, ozone generator, all systems go. The ozone generator start. And it's constantly monitoring itself. It always to make sure it's in the right parameters. Then what it does is it has an ORP If you don't know what ORP is, it stands for oxidation reduction potential. It is measuring the health of the water. And it's always a little hard to describe ORP because it's kind of hard to wrap your head around. Unless you look at the comparison, most people know what 2 parts per million chlorine means in the pool water. Would you guys agree? Yes. So if you know that under normal conditions, 650 to 750 millivolts, which is the unit of measure from the ORP, is equal to about 2 parts per million free available chlorine under normal pH, under swimming pool conditions. Can you jack something way out of yeah, you can, but under normal pool conditions. And the data have been well established, way back in the 60s, that 650 millivolt reading in a body of water can't grow any microorganisms. So the ORP is a very accurate means of measuring the health of the water. And it doesn't know the difference between chlorine in the water, although free available and combined, it knows the difference. Which is why some people will tell you that CYA, which is cyanic acid, which is a stabilizer in pool, affects ORP. And so you can't use it in ORP because it affects the ORP. What they're misconstruing is, yeah, it affects the ORP, not the monitor, but the health of the water. I think we all know if you have a very high CYA, you can have a high chlorine level, but your potential protection against microorganism growth in the water is not good. And that's what ORP is measuring. It's measuring the health of the water. And the correlation of the 650 to 750 millivolts and 2 parts per million chlorine is helpful, but it's really measuring the health of the water.
Our friends at Lamont were on the podcast a few weeks back where we discussed their story in the WaterLink Spin Touch, which brings their advanced technology out into the field. The patented WaterLink Spin Reagent Disc is used with the innovative photometer to measure 10 different tests in just 60 seconds and have those results displayed simultaneously on the photometer's touchscreen, along with the capability to send that data through Bluetooth to a smartphone or tablet. The photometer can measure free chlorine, bromine, total chlorine, combined chlorine, pH, alkalinity, hardness, cyanuric acid, copper, iron, phosphate, borate, biguanide shock, and salt. This is the most advanced system for precise use of wet chemistry methods ever produced. Pool and spa professionals can achieve precision without time-consuming tests and cleanup procedures. This groundbreaking analysis system is so simple, anyone can use it. No vials to fill, no prep time, and no guessing. To learn more, check out episode 136 of the podcast or click the link below.
So maybe explain a little bit of what it's actually doing for the water. Say I'm a homeowner and I'm saying, hey, I want the best water possible because I want it to feel different. I want to really enjoy this. Like, what exactly is the ozone doing to the water and why is it important?
Well, it's important because I love ozone, so that's the most important thing right there. Yeah. I've had this question posed to me about 5 kajillion, trizillion times. There's a lot to answer, but let's just give it the basics. So you have a body of water that you've got in your backyard or in your house, or it's your swimming pool, or your hot tub. But it's you want that water to look like it's a fresh, clear stream all the time. You want it to be healthy, clean, so you don't want any microorganisms in it. You want it to be clear. You want it to smell good. You want it to feel good. You want to know that it's healthy, especially if you're going to get in that water. So people will use, because a lot of water features out there, people don't swim in, but they still maybe they put their hand in it and they're going to smell it, or it's in the house. All of those conditions are important to everybody. Otherwise, you might as well just have a mud puddle back there. So in the swimming pool, you're recirculating the water because we know that recirculating the water keeps it alive, keeps it fresh, keeps it aerated, and then you're running it through a filter. So now you're filtering out the mechanical detritus that's in the water. And then, you have to put some sort of a chemical in there. So chlorine is the one that most people use. Then there's folks who have a salt chlorinator because they think they're not using chlorine, but they're making chlorine. So is there a benefit to that? Perhaps, but there's still chlorine. So ozone takes the place, and let me finish this before everybody freaks out. Oh, I can't say chlorine free. It takes the place of chlorine in doing the job of the primary sanitizer. So it's sanitizing the water. Remember, ozone is made of, it's pure oxygen. That's all it is. It just has 3 atoms. It's just oxygen. There's nothing else there. It's just oxygen. So when that ozone molecule bumps into something oxidizable or it gets old enough, it just falls apart and becomes oxygen again. What's the benefit to the homeowner? Very clean water, devoid of microorganisms. Very clear water because of your microfloc and your high oxidation. It doesn't have any taste. It doesn't have any odor. It doesn't burn your eyes. It doesn't leave any residual in the water. So if you wanted to go chlorine-free, you'd have to run the pool 24/7. And you'd have to have a big enough ozone generator in it. Most people do not. So the compromise is the ozone is the primary sanitizer, although if you're looking at the commercial pools, they'll call it secondary. If you're looking at it for municipal water, it's primary. They use only ozone. Now, on the pool we did yesterday, we're making 5 grams of ozone an hour on that 30,000-gallon pool. If you were, I'm not sure what you have in Phoenix, but if you were to go to the greater Dallas-Fort Worth area, their ozone system that handles the muni water for this greater metro area is 24,000 pounds of ozone a day.
Wow.
It's a lot. It's a massive, massive ozone systems. I have a friend who actually does the maintenance on one of these machines, and it's a full-time job. They're maintaining, cleaning these cells all the time. So a lot of ozone. I think that's the benefit to the homeowner. So again, this compromise is ozone does the primary sanitation and a lot of other benefits with the clarity of the water. And you could still maintain a small residual of chlorine. So during the time the ozone system's not running, because the filtration isn't running, you could get a couple algae spores over there on the steps. That little bit of chlorine will kill those algae spores. And it's protecting you from, so it's you got the best of both worlds. So swimwear doesn't get faded. The water is just spectacular. And then if you're putting ozone in and there's no load, what we call no inorganic load, it just falls apart. Remember I said it doesn't like to stay that way. So you can instantaneously drop that oxygen atom by bumping into something oxidizable, or if you boiled it, if you heat it, it'll just go back into oxygen, or if you just wait. So it'll just fall apart in time. Really, ozone, there's so much to go after in a swimming pool because it's not a sterile environment. You could have ozone could last in the water for 5 minutes, 10 minutes, 15 minutes, 1/1000th of a second, anything in between there. So it's safe to say it doesn't really leave a residual.
Right. Something I'm curious about, and I was thinking about yesterday, was if you were thinking about putting ozone on an existing pool that has nothing, would you advise getting an ORP probe or something and testing the water at its current state so that you can kind of compare, the new readings to the customer? That way, because we were talking a lot about like sharing or viewing the results, but it's hard with a brand new pool because you have nothing to compare it to. Where I'm like, oh, that'd be cool if there was a separate body of water that was treated just a certain way so that you could see like this could be like your normal water. But since you have ozone, this is what you're looking at. But I was just curious because there's probably a lot of people that curious enough to maybe want to put ozone on especially right now, with chlorine shortages and different things like that. But just to kind of wrap your head around it more, is it a good idea to have something?
Okay, I hope I understood the question. So let's say you have a swimming pool and you're just chlorinating it now. You wouldn't have an ORP on it? That wouldn't be normal? Is that what you're saying?
Not typically, unless you have an electronic fed system.
Okay.
Yeah.
So, yeah, you could go...
So are you saying that there would be no ORP readings?
Nobody would be reading it for you. You'd have to use a meter of some sort to read ORP.
Correct.
That's what I'm saying is buying an actual...
Yeah, you can get online and buy a Pinpoint ORP portable monitor for $100.
I already checked them out. Yeah, there's a ton of them, and they're all super expensive.
Yeah, get the Pinpoint. Just go to Amazon, Pinpoint ORP. It'll pop right up. I probably bought 50 of them. and I always give them away over the years. It's
Really?
like,
You got one right now?
you know what? I don't. I didn't bring it with. I can't find it. I was looking all over for it because I thought if somebody needed an extra ORP probe and something didn't come in the mail, I thought, well, I'll just bring that one and we'll just use that because I always have that. I can't find it anywhere. I don't know who has it. Like I said, I loan them out all the time. For $100, it's a battery operated, very accurate, handheld ORP with like at least a 15-foot cable, and you could just dangle the thing in the pool. There is some lure though to ORP. It doesn't like to be stagnant. It likes to have water movement. So if you're going to do that, you would swirl it in the water with your hand to get an accurate reading. You just want to put it in there and look and see. It takes some time to build up. Remember, we had the pool turned off yesterday. We started at 500 millivolts. It had been off for a while. And after 5 minutes even, I don't even know if it was 5 minutes, we were in the 800 millivolt, and then we finished out at 998. But so yes, I have done that a bunch of times. In fact, that's a common practice when somebody says, oh, my well water isn't very good and I'm not sure, should I put on ozone? We always put an ORP in there so we know what we're working with. I have one at home in my house in California. My water coming out of my well is in a negative ORP state. And so it pumps from the well up to 100-foot rise on the property, and then there's 2 big gravity holding tanks that gravity feed then down to the farm. It's just, I don't know why it's that way, it just is. And so I have ozone recirculating in those tanks, and it gets my ORP up, and then when it gravity feeds out, I filter it below. So I essentially have a bottled water system on the incoming water in that house. You'd never know. It was, if you had a blind taste that, you think it was bottled water. So yeah, if you can give somebody a visual on what you have and what you can have, and they don't have an ORP monitor on that pool, you could go in there with the handheld and say, here's what you've got. Then you put the ozone on, and it's automatically going to tell you what it has because ORP is built into it. The MicroPlasma is, not all of them.
So, I mean, you've had decades and decades of experience now of it. That's why we wanted to share all of that, which leads up to what you're kind of doing now. And I know you shared an article with us that talked about, when you went to the facility, you finally found a system that you were excited about and wanted to see.
Yep.
So can you share more about that? Like what's led you to this system and why you've put your expertise behind it?
Absolutely. There's a company in Champaign, Illinois. As you know, I've been in this for a long time, and I was approached for actually a couple of years from different sources about this ozone technology that came out of the University of Illinois. And it was work done in the plasma lab in the physics department at the University of Illinois under some government funding trying to develop plasma. And what they discovered was they could make ozone with this microplasma. And I remember in the beginning of our conversation, you've got electrical energy, light energy for making ozone, electrical energy would be corona discharge, and the modern version is plasma. So there's big plasma ozone generators out there, but there was never any microplasma. So what they developed, and the patents are owned by the university, and MicroPlasma Ozone Technology, Inc., the company, owns the rights, the exclusive rights to those patents. And so they make a lot more ozone in a much smaller space for a lot less energy, and they're smart. So in my Dell world, and I left Dell when it was purchased by another company, and I worked in consulting, and mostly food processing for 4 years. I still have a consulting license. It's dormant now. People call, and I just give them some advice. I don't go do audits in food processing plants to figure out where the best to use ozone. And so invited me to come look at it, and I was busy, and it took me a while to get there. I finally got there. I looked at this technology, and I was, I have to tell you, as cynical as I am about small ozone systems, because I like big stuff, I was so impressed with what they had developed, because they've got the ozone production down beautifully with the plasma, but that smart driver I was describing a little bit earlier is something you would find on a very large commercial ozone system. and built-in ORP and built-in flow of the solenoid valve and the vacuum sensor and the flow sensor and the temperature and the humidity and the ORP and the touch screen. That is a very sophisticated, very lovely, very nice, very desirable commercial ozone system that you would see in any application where you need a big ozone system, that they just miniaturized. And so they didn't, and what I had seen in the pool industry especially is companies that had a very basic ozone generator and it was cheap and it does its thing. And then other companies that have that same guts inside, that same basic ozone generator, but it's packaged really prettily and it looks neat, but it's still the same stuff. And then companies that have what I consider somewhat mediocre commercial generator that they pass off as a residential system, or they took out some of the things that a commercial one should have to make it affordable. So they took away the very part that makes it what it should be in the first place. So this little company, it's the first one I've ever seen that had done everything it's not super cheap, but it's an affordable package that makes 4 times more ozone than the biggest competitor on its smallest unit, and then, 20, 30, 40 times more than other ones. And anybody can run it. You just go and look at it, and if it isn't working properly, it tells you why. And you can say, oh, well, it says that, something's wrong over here. And then you can reach in and pull out this little SD card, pop it in your SD card reader, go to our website, there's a portal, you can upload it, and our engineers can say, oh, well, here's a problem. You didn't have this plugged in, or the power was out for 6 weeks, or it's measuring 17 data points every minute in real time, the whole time this machine is turned on. And then when the machine isn't on, it's clocking its time. So you know what the time value is, even without power. It's got a little tiny battery in it. So that's what got me. I looked at this equipment and I thought, wow, if the companies I worked for in the past had this technology that looked like this, it would have been just a massive game changer, because they had such a brand name. It's, I just said what they were missing was the degas, the destruct, the Mozzie, to be designed specifically for the average range in a backyard pool. And they hadn't run it through NSF, and they hadn't taken it through UL for outdoor listing, for waterproof outdoor. And I said, this is what you guys need to do, and then market this product, because people will just love it. It's so cool. And they said, well, yay, help us. And I go, no. I'm doing vegetables, man. And they said, just please help us. And I just couldn't resist. So that's why I support MicroPlasma Ozone. That's why I'm here talking to you. That's not the reason. I think you guys are great, and I feel very honored to be chatting with you. But that, I think, is a major contribution to the backyard pool market. And for me, it's not, oh, let's see how many ozone generators we can sell. I mean, we're all in business. We have to make money, or we wouldn't feed our kids, or in my case, my horses. My kids are old enough to feed themselves. I don't want to sound corny here, but it helps people. It helps the environment. It's the right thing to do. If it was a magic world, I would give everybody one, because I think everybody would like to have an ozone generator. But I haven't figured out how to make them for free yet. So when I figure that out, I won't need to worry about anything. But
and everything you're talking about is like much higher end technology than some of the basic, residential systems we've seen out there. And I remember you told me the other day about one of the most common things you hear is, do you know what ozone is? Yeah, I know what it looks like, and I unplug it because it doesn't work. Right?
Yeah.
Like, I think that's the thought process amongst some of the industry, is just that it's this box that they have no idea if it's working, other than what they've been told. Is there bubbles? Yes, And so
exactly.
It's such a different type of system, and allows you to actually see if it's working or not. I mean, there's a big green light on it that shows you. But not only that, I mean, that's more the simplistic version,
Yeah,
right?
right.
But the touch screen and everything that shows you all that, it's so much more advanced than just a box on the wall with a cord plugged in that you don't know if it's working. Right?
You're absolutely right. You know, at a glance, you can look at the touch screen and your ORP readout is right there. Your gas flow is right there. Your temperature is right there. The health of the module is there. The driver health is there. I guess I'm trying to think what else is on there. I'm doing it from memory. And the ORP is probably the most critical.
Sure.
Because if you don't have a chlorinator that has its own ORP, you know that your ORP that you're getting is coming from the ozone. You can see that number. If you turn it off and wait for a few hours, that number is just going to go down, 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 down. And you'll know that the ozone did that. And then if you turn it back on, it's going to go up, 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 up. There'll be some holding place. It won't drop down to zero.
Sure.
You know, it'll take some time. It'll just depend on how contaminated the environment is. Like if you were to turn the ozone generator off right before a major Arizona dust storm or right before a Florida thunderstorm with a a screen porch above it that once the rain rains down, it rains all that dirt right into the pool, it would go down pretty fast. But that's what I love about the technology. There's no guessing, and there's no bubbles in the water. The lights on, there's bubbles in the water. Somebody must be home. Never struck me well, never, and which is why I didn't like the residential pool ozone market. I never liked it, not with any of the companies I worked for in the past. I didn't like it because I knew we were just maybe put enough in there. You know, there's a big placebo effect. Human brains are very susceptible to placebos. So, and that's why they do these blind studies, right? You get 50 people and 50 people and half of the 50 people who got a sugar pill, that, oh yeah, I felt so much better. It's great. You know, and the other half of people are like, I'm still sick. And then you want something to work. You believe it works. I bought this ozone generator, and nobody buys an ozone generator thinking, well, you know, it's no big deal. You spend money on it. You spend time on it. You want it to work. You expect it to work. And I think a lot of people think it does. And I can prove this beyond the shadow of a doubt. I can't tell you how many times somebody told me how fantastic their pool was with their ozone. I mean, they're just like gushing over it. And you go there and the generator's not even plugged in. Or it's 100 years old, you know, it's not making any ozone because they really wanted it to work. And that's the frustrating part, because then the guy who comes and says, well, they thought it worked, they unplugged it, they didn't even notice the difference because it was never doing what it was supposed to do in the first place. I promise you, if you went and unplugged that unit we were playing with yesterday, the homeowner would be calling you up freaking out because his water, he could see the change and the ORP's down.
He probably feels a difference in the water quality.
And he feels a difference in the, yeah. And, you know, I've done commercial pools by the droves where you had long-term swimmers, you know, lap swimmers, where they swam every day. And if that ozone generator wasn't working, they wouldn't get in that pool. And so that's my story about that.
So we talked about a lot today, and you know, if people want to hear more information or find out more and learn more of what you talked about, where can they find that?
Okay, so we have a website. First and foremost, a website. Our company is MicroPlasma Ozone Technologies, Inc., and we go by MPO3 Tech. So M as in Mary, P as in Paul, O as in Oscar. It's the letter O. Three.
The number.
The number 3, TECH.com. So MPO3tech.com. We're working on videos. We don't have as many videos as I would like to have, but we can. So there's the website. You can download a questionnaire on the website and hit the go button. And if you have a pool in mind, we can look at, if you fill out the questionnaire, we can look at everything you have and make some suggestions, can give you a call, can discuss it with you. If you already have a pool with ozone on it and you want to talk about any issues there's a questionnaire for that. You can also download a brochure. You can download a PowerPoint that's very briefly talks about maybe a tenth of what we talked about in this podcast. Quite frankly, you can download our owner's manual. Our owner's manual is about 55 pages, and it is extraordinarily helpful and answers. I don't think anybody's ever asked me a question about microplasma technology that wasn't answered in the owner's manual. Beyond that, I am personally always happy to have somebody call and discuss ozone. If I'm busy and I don't have time, I will send a text and let you know who you can talk to. We are a small company. There are several people who can answer your questions, but I'm generally the first go-to person at this juncture. Maybe in another 2 years, there'll be more people. There are more, but I like to answer the questions myself. I welcome emails. I welcome text messages. I welcome calling me on the phone. My phone number is area code 805-441-4444. That's cell, and you can text or call that number. And then if you go on the website, mpo3tech.com, any of those contacts that you fill out information form, I get a copy of that too. I'm easy to find. And if I'm busy, I will switch you to somebody else who will give you that same information. But our goal, we manufacture the equipment, we have them in inventory, we can sell them, we can ship them, we can talk to you about any application that you may have. We don't just do pools, we do other applications. So we welcome any form of communication.
Yeah.
That's awesome. That might be the first cell phone number we've heard on the phone number. Beware.
Yeah. I mean, I've heard, I've talked to you over several months now at different conversations we've had. I've heard several seminars that you've given prior to that. And, our mutual friend, Greg Garrett, I've heard you called the Greg Garrett of ozone. I've heard all kinds of compliments towards you. And I think that's a very high compliment because we all know how diligent Greg was with surfaces. So, it's a true honor that you've come down here, and it means a lot to us. And I think you are, in my eyes at least, the guru of ozone, and so really appreciate you sharing all that with us today and spending the time to come down here and go out with us to the pool yesterday. And just we really appreciate everything, all your accolades that you've accomplished. We didn't even get into a lot of those, but it's an honor for us to be here with you.
Well, I have thoroughly enjoyed the fact that you guys stayed awake the whole time while I was droning about ozone, and I'm teasing. I can tell that you're as passionate about all of this as I am. I know you are. I will continue to do this until I'm too old to talk, and I'm pretty sure that's not going to happen until I'm pretty much done. So I will continue to do this, and I'm thrilled to meet you guys. I'm thrilled to do this. I thank you from the bottom of my little heart. This has been great. Please don't hesitate to ask me any ozone questions.
Right. Thank you so much, Beth.
Thanks, guys. Have a great day.
You too.
Hey, Pool Chasers. Thanks for listening. We hope you enjoyed the episode. To connect with today's guests, including pictures, links, and resources from everything discussed today, you can visit the episode page at poolchasers.com or click the links below. To connect more with us, you can find us on Instagram, Facebook, and Twitter by searching at Pool Chasers. If you would like to support the podcast, the easiest and most effective way is to subscribe to the show on Apple Podcasts, Spotify, and YouTube, as well as share the show or your favorite episode with a friend or on social media. Also, you can get early access to each episode by supporting us through Patreon. We know your time is valuable, so thank you for sharing some of yours with us today.
See you out there, Pool Chasers.